So if you have questions, by all means, bring them up. Make sure that we answer them. Let's take a look at what we have for the week. So yesterday was the asynchronous, whatever they call it, day. You were to do page 7 and 8. We're going to go over the answers for that today. Tomorrow, we're going to review that. Probably tomorrow, if we have time, we're going to get into partial pressures. Wednesday, basically, it'll be a real short thing. Oh, wait, I'm sorry. Review. Tomorrow, Wednesday, will be a very short review, and then you'll have time to do the combined gas cell homework quiz. It's basically similar to the problems that you did yesterday. And so you'll go here, and then you'll click on the homework quiz. And that will allow you to write on this sheet after you download it, just like the Mythbuster thing that some of you guys are already ahead on the Mythbuster thing. That's awesome. But you'll be able to write the answers here and work through it. But it's 5 problems. Each problem is worth 5 points. Keep in mind that correct answer is worth 3 points. Significant digits is worth 1 point, and units is worth 1 point as well. So all of those things are involved in that. Cool. Let's go ahead then and take a look at the work we did yesterday. So we did problems 1 and 2. So I got about 1/5 of it done for you. Let's take a look at problem 3. It says, what is the volume of the same gas at STP? So we have a gas. Looks like we have P1 V1 over T1 Not sure why I wrote T2 there. Let's get my white out. Mine was just ahead of itself, I guess. T1 equals P2 V2 over T2. It says we have the gas, we have the volume, temperature, 22 plus 273.
The answer is 295.
So what is the volume? We're looking for V2. So I'm going to rearrange this equation to solve for V2. That means I'm going to multiply both sides by T2 and divide both sides by P2. It's going to cancel out over here. So T2 is 273 Kelvin. P1 is 952 millimeters of mercury. V1 is 112 liters. P2 is 760 millimeters of mercury. And T1 is 295 Kelvin. So if we take a look at that, our kelvins and our millimeters of mercury are going to cancel out. We're going to get liters, which is what we want. 273 times 952 times 112 divided by 295 divided by 760.
It's about 129.832.
So we have 129.8, which comes to 130 liters. We do need that dot there to show that that is 3 significant digits. Questions there? 4. A compressed air cylinder holds 10 liters of air at a pressure of this. What volume will the same gas occupy at this pressure? So we only have pressure and volume here. So it's P1 V1 equals P2 V2. This is what volume. So we're looking for V2. So we need to take P1 V1 divided by P2. That cancels out. So we get 16.7 atmosphere, 10 liters, all over 0.950 atmosphere. Atmospheres cancel out. 16.7 times 10 times 16.7 times 10 divided by 0.950.
The answer is about 175.7894.
You only have two significant digits, so 175 is going to become 180 liters. Yeah. So the pressure went way down, so the volume must have went way up, which makes sense. Questions so far? Remember, I don't look at the chat, so it's best if you verbally ask questions.
Can you go back down really quick to the last problem?
Yep. Can I show it to you? Is that what you want?
Yes.
Yeah. There you go.
Okay, thank you.
You're welcome. So here they want us to make a graph. So we have 0 Kelvin, 100 Kelvin, 200 Kelvin, 300 Kelvin, 400 Kelvin, 500 Kelvin, 600 Kelvin, 700 Kelvin. They tell us that at 2.50 milliliters and 300 Kelvin, well, they want to know what these are. So we take a look. .50 milliliters, 300 Kelvin, 2.50 divided by 300.
That would be about 0.008333.
0.00833 times the temperature equals the volume. So there's my formula. Basically, I just need to put that in for everything. 0.00833 times 100.
The answer is 0.833.
That's easy enough. So we get 0.833 at 100. We know at 0, it will take up 0 volume. 0.833. 0.0833 times 200.
It's 16.66.
0.00833 times 200.
The answer is 1.666.
1.666. 0.00833 times 300.
The answer is 2.499.
2.499. Oh, that should be here. 0.00833 times 400.
The answer is 3.332.
0.00833 times 500.
It's 4.165.
0.00833 times 600.
It's 4.998.
4.998. 0.00833 times 700.
The answer is 5.831.
There you go. As you can see, makes a decent straight line, which makes sense. As temperature goes up, volume goes up. We said they are directly proportional. What is the temperature in Celsius of 2,500 milliliters of nitrogen gas at 750 millimeters of mercury? The same gas fills 1,500 millimeters at 12 degrees Celsius and 750 millimeters of mercury. 12 plus 273.
It's 85.
Is that right? 12 plus 273.
answer is 280.
There we go. P1 V1 over T1 equals P2 V2 over T2. We want to rearrange this equation so that it solves for T2. This is a tricky part. We got to get T2 up the top. So that means we cross multiply. And we rearrange everything so that T2 equals P2 V2 T2 divided by, I'm sorry, that should be T1. P2 V2 T1 divided by P1 V1. So P2, 715. V2, 1500. T1, 285. P1, 715. V1, 1500. Oh, I messed this up. This should be 2500, and this should be 1500. There we go. Did I make any other mistakes? I did. 750. There we go. Sorry about that. If you guys don't have whiteout, that's going to suck, but this should be our 750. This should be our 2500. This should be our 285. This should be our original 715 and 1500. 750 times 2500 times 285 divided by 715. I'm sorry, I messed it up. 750 times 2500 times 285 divided by 715 divided by 1500.
It's about 498.2517.
So 498. Problem with this is in Kelvin. So we need to subtract 273. 498 minus 273. Oh, you messed that way up. 498 minus 273.
That would be 225.
225 degrees Celsius.
Wait, why is 2500 V, wouldn't 2500 V2? Because I have it down as V1.
You could have switched all of these. The problem is that basically I said this is the final stuff because the same gas originally filled this. Did you Did you end up with 225?
No, I put the V1 and V2. I switched those two on accident.
Yeah. So basically, as long as you keep all of these three together as either P1 V1 T1 or P2 V2 T2, it's not going to matter as long as you keep all three of these together as the same like initial or final. We have 777 gallons. That's a volume at 7.7 atmospheres. What's the volume at 3.3 atmospheres? So V1, actually P1 V1 equals P2 V2. We don't need T here because it's not mentioned, so it's constant. They want volume, so we're going to divide both sides by P2. So V2 equals 7.7 atmosphere times 777 gallons divided by 3.3 atmosphere. 7.7 times 777 divided by 3.3.
The answer is 1,813.
So we get 1,813 gallons. That actually should just become 1,800 gallons. If we take a look, The pressure went down, so the volume must have gone up. Cool. The diagram below left the diagram below left shows a box containing gas molecules 25 degrees Celsius, which is 298 Kelvin, and 1 atmosphere. The piston is free to move. The piston is just this top part that can move up and down. In the box at the right, sketch the arrangement of molecules and position of the piston at standard temperature pressure. Does the volume decrease significantly? Why or why not? So we get standard pressure. Well, standard pressure is 1 atmosphere, so pressure doesn't change. So we get V1 over T1 equals V2 over T2. So we want to solve for volume 2, so we multiply both sides by T2. Standard temperature is 273 Kelvin. The original volume is, oh, they don't give it to us, so let's just put 1.00 liters. The initial temperature is 25, which is 298 Kelvin. 273 times 1 divided by 298.
It's about 0.9161.
0.9161 or 92 liters. So if this is at 1 liter, we need to do 0.92 liters here. So we're going to take 1/10 of this. We're going to cut that off. We're going to move that piston down. Now keep in mind that the number of particles here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, needs to remain the same. Number of particles remains the same, but the volume has decreased. So the temperature was decreased, so the particles stopped hitting the wall as often. It caused the pressure to, well, the pressure remained the same. So that if that's going to happen, the volume must have decreased. Volume must have went down. Questions about 7 or 8? You are more than welcome to go do this quiz, the combined homework, the combined gas law homework quiz. There's 5 problems. Keep in mind that does not have to be turned in until tomorrow.
Wait, why are there 2 of those? Are they the same ones or like 2 different quizzes?
They're different.
Okay.
Different people have different quizzes, just to prevent like direct copying.
So does it matter which one we do?
You'll only have the option to do one.
Wait, what do you mean? Because I have like 2 different quizzes.
You can actually click on both of them.
Okay.
Can you?
Yeah, I believe so.
I can check mine right now. I don't know though.
Yeah, that's interesting. It's set up so that you only have one choice in my mind.
I have one that's due on the 13th and then the other one's due on the 14th. Yeah, like that. But I don't know which one to do. I can look right now.
13, and one that is due on the 14th. What are you looking at?
Like I'm looking at the home page. Like the home page gives me like what's coming up, like things that I haven't done. And so it says combined gas. Huh?
Yeah, that's the worst. That's actually not the best way to do things by looking at the homepage. It's best to look at the module. But yeah, this was some other one that, yeah, that this was one that was imported. So that wasn't an assignment. I think I took it off of yours. Refresh.
Okay, okay.
Did it change?
I'm looking. Yep, it did.
Good. Yeah, this was,
Thank you.
yeah, this one, actually this one would be fine. Maybe we'll give this one as the makeup. But some of these quizzes would have kilopascals, which we've not dealt with a lot. But you can take a look. This one has atmospheres only and liters and stuff like that. But yeah, cool. Thanks for pointing that out because
Yeah.
you only have the option to do one.
How long does it take you to like upload like the videos that you take in class?
Like today's video,
Yeah.
it'll be up after homeroom.
Okay, thank you.
You're welcome. Any other questions? Then I think we got it. I think hopefully we've discussed everything that you guys needed. If you need anything else, it's homeroom today. It's not teacher support hours, but we actually have 20 minutes left of class. You're more than welcome to get out of here, go do what you need to do. If you do have questions, by all means, stick around. Have a great day, guys.
Thanks.
So
Thank
even
you.
though in current work it says that it's for tomorrow, you want us to do it today?
No. I said you can do it today. Yeah, so let me show you real quick. So yeah, and to tell you the truth, some of you guys are, and maybe I'm not being clear on this or whatnot, but some of you guys have already gotten like the Mythbuster that's due Thursday done, which is amazing. I'm not sure why you chose to do that. It's totally up to you.
It was due yesterday. That's why I did the Mythbusters, because I thought that was Monday somewhere, because it said Monday at 11:59.
Dang. Yeah, you guys are following you guys are following the whatchamacallit, aren't you? That's what it is. You're better off following the module week. See, I didn't even realize that this actually said due on that day. This should be due this day. There you go. Thank you very much for doing it, but I'm sorry that I put you through that. But you're best off following the actual schedule. So whoever just asked if I wanted you to do it today, as I said, you're more than welcome to do it today, but the combined gas law homework quiz is due tomorrow. The dates on here are the dates that are the ones that matter in a sense, I guess. Sometimes whenever I make these assignments, I make them 2 weeks in advance. So whenever I'm sitting there thinking about it, I'm like, oh, maybe we'll have it done that day. These are this is the agenda for the week. I'm sorry about that, but yeah, that means that you got Thursday off completely. Yay. But if you do have any questions, by all means, stick around. Otherwise, I'll see you guys.
Yeah, I actually have a question. Can you do a problem like using the P1 V1 over like T1 like problem again, equation again?
Yeah.
Okay, thank you.
Let's see if we have any practice problems left in here. Maybe there's a review or something. Here we go. So gas problems, you may need to use any of these. So let's take a look. This says moles, so that's our next week's topic. So we don't want to do that one. This one right here will work. It says a sample of oxygen is 30 degrees Celsius, 273 plus 30.
The answer is 303.
Fills a volume of 50 liters. If the temperature is raised to 50 degrees Celsius, 273 plus 50.
The answer is 323.
And the pressure is held constant. So that means that we don't need to deal with pressure because P1 equals P2. What volume will the same sample occupy? So we have P1 V1 over T1 equals P2 V2 over T2. We don't need to worry about pressure because pressure is constant. So V1 over T1 equals V2 over T2. It says what volume will the same sample occupy as the temperature is raised? So we need to solve for volume. So we're going to divide, multiply both sides by T2. That's going to cause it to cancel out there. T2, as we said, is 323 Kelvin. V1 is 50 liters. T1 is 303 Kelvin. 323 times 50 divided by 303.
It's about 53.3003.
So the temperature went up. That means that the volume should also increase, and it increased by 3 liters.
Wait, did you multiply the 323 Kelvin times the 50?
Yeah.
Oh, we're allowed to do that even though they don't have like the same unit?
So if we take a look, when we multiply that, we would get Kelvin liters. But since we have Kelvin down here, that Kelvin will cancel out.
Oh, okay, okay. I see, I see. So with that 303 that you have up there, that's from the 273 plus 30?
Yep, that's the initial temperature.
Okay, okay, makes sense. So basically we just have to like plug in like the numbers into the formula?
You got it.
Okay,
Yep, that's the
and
easiest way. Yeah.
okay, and every time I see you like always put like the V1 and then the P1 equals P2. Will those always be like in that order that you're putting them in?
Actually, we had an interesting thing. I don't know if you got in here on time, but we had an interesting one. Basically, as long as you keep the ones together, like make sure that these are either T1 V1 or T2 V2. As long as these two, because it says that it's together,
Yeah.
as long as you keep them together, then it's fine.
Okay. Thank you.
You're welcome.
Have a good day.
You too.